would first like to congratulate all the students who participated in the quiz competition. All done very well. Big claps to them. So my name is Rajat Verma. I'm going to talk about sand and technology. So looking at this title here, sand and technology, any guess what will be I'm talking about? Any guess? Wild guess? Just whatever you can say. Yes. What will be I going to talk about? I'm going to start with sand or something else. Okay. So my first question to the students, just general question: where you can find sand on the earth? Yeah? Good one. Beach. Yeah. Where else? Excellent. Good one. Excellent. So, how many of you been to beach and deserts? You've been to beach, definitely. Anyone that visited desert in Dubai or Rajasthan or Sahara or somewhere else? No? I can put my hand up and I say I haven't visited desert yet, but definitely a lot of beaches. You be familiar? You sitting here and making sand castles on the beach? Everyone familiar? Have everyone done that? Yeah? You're going to do more when you visit the beach next time, right? So you're very familiar with the sand, right? So my next question. What is this sand used? It's only not to make not as a play substance, but in the real world. Where do you use the sand? Yes, I can see some of the hands. You can shout from there. What? Glass? Yeah. Yeah? Speak out. Speak out. Oh, very good, very good. Excellent answers. Excellent answers. Very good. Sand used in building dams. Anyone seen the dams? Built with sands and concrete buildings? Yeah? There's a concrete, sand is the main component in the concrete that's been used to make the buildings. It makes the concrete hard. What if I say sand is used in everyday electronics? The electronics that you use today, your parents uses, that the one that you have it in your hand. Somebody may have smartphones or tablets or computers, laptops, PS4 or whatever you have it in your house as a gadgets. Yeah, everyone has seen obviously have seen a laptop or a tablet or a smartphones. I waited until year 27 or 30 years to see a smartphone, but nowadays kids will see a smartphone at least when they are immediately born, right? The technology has advanced so much. So what drives this electronic systems? Yeah? So if you put your hand up, just shout, right? I cannot, it's very difficult to reach everyone out there, so you can shout and answer. Yeah. Exact. Good. Very good. Yourself. Very good. Very smart people out here. I'm glad to know that. Yeah. So microchips or microprocessors, which is used in everyday life, right? Laptops that you use. This laptops, smartphones, medical devices, automobiles, aircraft, telecommunication systems, right? So this is a kind of an example. If you open your smartphone, you can see that small square thing there. This is a microprocessor that does all the jobs, right? You can see that one in one of the computers or whatever the electronic components you buy from the market. So what drives this microprocessors, basically? What drives it? Yeah, I can see a hand up there. Yeah, shout. Yeah, sand. What type of, like, sand is not the exact answer, I can say you, but it might be a difficult question to the young ones, so I can help you with that. It's called transistors, the small things that drives all the microprocessors, right? So, what is this transistor? You can still see a hand there. Yeah. It's a switch. Yeah. Very good. Very good answer. I didn't get all that, but I got the concept. It is an electronic. It acts as a switch. Very good. Very good. Yeah. The answer is here. Anyways, transistor is a device that regulates the current or voltage flow and acts as an electronic switch. So this is what transistor does. Either in an on state with the, like this is an example, either in on state or an off state. So on state we call 1, and off state we call 0. So that's how it transmits the electronic signals, either in 1 state or a 0 states. It switches between 1 and 0s. So the first transistor is invented in the Bell Laboratories in 1947 by 3 scientists. And these transistors are made of semiconducting materials. And what is a semiconducting material, by the way? What is a metal? What is a semiconductor? What is an insulator? Anyone? I can see one of the common hand over here. Okay. Give me an example of a metal. Anyone? Any metal? Yeah. Yeah. Any metal? Shout, shout. Yeah. Copper. Yeah. Very good. Yeah. An insulator. Example of an insulator. Anyone? Wood. Good. So I'm just quoting an example or showing an example of how does this 1 and 0 converts to a meaningful number. It's 1 and 0, 1 and 0. This is how the signal is transferred through the microprocessor processes it. And it's converted to decimal, or it's an example here. So if I take this example here as 1 0 1 0, the switch on switch off of the transistor here, you can see here I can make it into a meaningful number 42 here. This is what we call, you convert from a binary to decimal here. So you just do the 2 raised to 0, 2 raised to 1 and multiply with 1 0 1 0 here, and you get the number here. So you probably will learn about this when you go to higher classes, or you already know about it. So I'm not going to much details into here. This may be very complicated if I go more details. So this is what it's called. So this is how the computer transistor works. It works either 1 or 0, and you can convert the 1 0 information into a meaningful output language, which you read it when you look into your computer, or when you ask the computer to do some calculations and all. So I'm just, so what is the difference between metal, insulator, and a semiconductor? You can see that this is the conductor. You can see it in conductor. So the valence and the conductance bands. So when I talk about these bands, are the energy levels where the electrons are located. In metal, the valence and conduction bands are overlapping. So the electrons in the conduction band, the electrons from the valence band can go to conduction band and it can flow freely. So so that means there is no hindrance for the electron to flow, which makes a conductor, a metal or a material good conductor. In insulator, you have this gap between valence band and a conduction band here. So it will be very high for an electron to jump into conduction band, and it will never conduct electricity. So that's an insulator here. And in semiconductor, this gap is lowered. So material have a semiconductor property. This gap is very minimal, so that it can conduct electricity at certain conditions. So that's why it's called semiconductor. So now we are making it more meaningful why I use the term sand in my presentation here. Silicon is the main component of the sand, and it's a natural semiconductor material, and it's most available in the earth, the sand. So, and you can get silicon, and silicon is a semiconductor because, as I said before, the electrons in the conduction band can move from valence band more quickly, and it conduct electricity. So how many of you have seen the periodic table in your school so far? You can see a few hands up here. Okay, the answer is here, but what does a silicon falls into? Which group of elements? Silicon falls into group 4 elements, which means silicon has 4 valence electrons, right? I can see some guys who are running around. Can I request them to take a seat, please? So why is silicon having semiconductor properties? So silicon contains 4 valence electron, and this valence electron, a bit of energy, it can escape and travel through the crystal lattice, and thus it can conduct some electricity. So as I said, it's the band gap between the valence and conduction band is small, so it can easily conduct electricity. What are dopants? Have you ever heard the word dopant in any other news or any other, like in sports especially, you might have heard dopants. Actually, dopants is a material that you can inject into a substance and increase its performance, basically. So we are doing same thing here. We are putting some impurities into the silicon lattice to make it more conducting. How can we do that? Or what should I choose? So I can either choose element like boron from group 3 or phosphorus from group 5. What happens if I put boron or phosphorus? So boron 3 has a 3 valence electron because it's a group 3 element, and phosphorus has a 5 valence electron because it's a group 5 element. So you can see if I dope boron, the 3 valence electron of the boron combines with the 3 valence electron of the silicon, and you are left with a hole there. So it will we make it a positive, more positive, because you have a hole there. And if I dope with the phosphorus, that means it has 5 valence electron, And when I add phosphorus into silicon lattice, it combines with 4 other electrons with the silicon, but you have remaining 1 free electron is there. So that means it is more negative because you have 1 spare of electron. So with the boron, when I dope boron into silicon lattice, I call it a p-type semiconductor, and when I dope phosphorus, I call an n-type semiconductor. This is what it looks like in a pictorial form, like a kind of a transistor. It's mainly of a 0 state now. So you can see it's an NPN transistor. It has both N-type and P-type semiconductor into the base material here. So it has a source, it has a drain, and it has a gate. And so right now it's electrically neutral because already the N electrons has attracted towards the P-type semiconductor, and across here they form a layer, high density of electrons over here. So any more electrons from N-type will repel because it has already negative charge, right? So this is a 0 state right now. So the transistor is in off state, right? Everybody getting that? So if I put some voltage here on the gate here, we will get some positive charge. I'm not sure it's clear from the screen here, but you get some positive charge when you put it builds up positive charge, which makes this a small path along here, and it start conducting again. So now it's on state. So this happens quickly in a microprocessor. The transistors happens quickly. The switch on, switch off process happens quickly, and the signals are communicated across. That's how you get the signals, and that signals is converting to a meaningful language or whatever you do on your computer, say a cartoon or program or calculations, all those stuff. So this is an electron microscopic image of a transistor here. So transistors are getting very small nowadays, so you cannot see with your naked eye. You need a highly specialized microscope to view it. So it's very tiny. So this is just I'm quoting here. It's called Moore's law. So Moore is one of the founder of Intel. He actually said that every 2 years the size of the transistor reduces half, and actually you can actually incorporate more transistor into a microprocessor, like so every year. So the first transistors was built with the size of the thumb when it was built. Now it's so small that I can put 4,000 to 5,000 transistors onto the top of this pen nib. So that's small. So this is what is the consequence of this one. So 20 years ago, this is an old picture. 20 years ago, I'm not sure if you can see that, but 20 years ago you might have seen big, what do you call, big cameras, big radios, big phones, big musical instruments. Now what can you get in the market now? Everything that can fit into your pocket. So this is the result of the reducing size of this material, transistors. So here are some fun facts, right? What's 1 meter? How many? So the transistors what we are dealing with is in nanometer size. the nanometer size. So 1 billion of nanometer makes 1 meter. Yeah, everyone get that? So how many zeros? 9 zeros, right? So nanometer is so small that it takes a billion to make it. What happens if you stack a billion of sheet of papers? If you stack billion papers, what happens? It makes 100 kilometer high, right? And if you can walk billion steps, you could cover the earth 20 times. So that's what it is, nanometer. Like 1 billion of nanometer makes 1 meter. So the nanometer is so small. And right now the nanometer, like the semiconductor companies are building nanometer of 22, 32, even 14 nanometer sizes. This is what I'm previously mentioning. The transistor size. So the first transistors are built of the size of a thumb. You can see, everyone can see the thumb. Now you cannot see with your naked eyes. And you can fit around 100 million of transistors onto the head of a pin. So you can imagine how small the transistors are. And this is what it drives the whole world now with the technology. Another fun fact, if you take your hair, and if I cut it and put it under microscope, you can see the width of the hair, which is in microns, and actually around 4,000 to 5,000 transistors you can build onto the width of your hair. So this is what is happening nowadays. So this is another fun fact. A 32 nanometer transistor can switch on and off 300 billion times in 1 second. 300 billion times. So if you are the person trying to switch on and off a switch 300 billion times, it will take 4,000 years. So let's start the journey from the sand to a microprocessor. I'm just going to give you a brief description here. So sand, we collect. So silicon is obtained from the sand and it's purified, right? It's melted and it's cooled and formed an ingot here. Now it's sliced into wafers. You all know about what wafer is, kind of a silicon disk, what I call it. And then in the fab, we all put this bunny suits. So the word is this process is a clean room. It's what we call a clean room. All the microprocessor fabs are clean room, and it is 1,000 times cleaner than an operation theater in the hospitals. So you cannot have any defects in there. So this bunny suits will help not to contaminate the fab with any human dead cells, and it's static free, so you won't get any static current, which may kill the microprocessors. And these are made in the billion-dollar factory, where you can see a lot of machines here. The clarity is a bit poor here, but this right side is the billion-dollar factory, and all the robots and everything is there, which makes this processor. And the processor creation or the manufacturing process contains several hundreds of steps. So you can see this is a microscopic image. You can see several layers are put one on top of the other to make it functional. To make the transistors functional, and once all the processes are completed, it's sorted and made into a chip kind of. They cut a piece, whatever necessary, and put it onto the circuit board of the computer, laptops, mobile phones, or all the electronic devices. So that's where you can see the microprocessor on a computer board. Has anyone opened a laptop or a mobile phone here to see the green board with a lot of electronic components? Anyone has done that? If not, I will recommend go to the house, not to open a functional one, but if you have a broken laptop or anything, you can go for it and see what's there, and you can see a microprocessor there and other electronic components which are all made of this small tiny transistors. You won't be able to see transistors because it's not possible to see with your naked eye. So I just said about the SAN journey, what is happening in the manufacturing, how the sand is turning into a transistor here quickly. Now I relate this to relate a manufacturing process in any industry, including semiconductor industry, to something common that you all know is the manufacturing of a bread. You all love bread. Anyone that hates bread here? Or anyone has not eaten any bread so far? I guess there will be no hands here. So you can see, consider a bread manufacturing factory here, which creates around 30 to 60,000 breads per day, and which may include 30 different or several different types of breads. Some may have grains, some may be sweet, some may be a little bit salty, some may be multigrain. You can see a lot of different types of bread in the Super Value or Tesco's or wherever you go for shopping. So what is the process for bread? Anyone knows? Anyone know bakery here? So what are the ingredients needed for bread? Let's go through the process. Yeah, wheat, flour, sugar, salt, yeast, yeah? And all those mixed, then they make a dough. The dough may be created into some sort of shape, like a square or round or a baguette shape, whatever. And then that goes to an oven. And then it's taken out, and it's weighed, and then it's compressed, and then it's cooked again, and it's packed, right? So if a bread manufacturing company has all this process, what should we do? What should they do to make the good bread coming out of the factory, tasty bread? They should have good raw materials, right? They should include good raw materials. It should be in a controlled process. For example, if I say the process of some robot putting salt or sugar, or even the oven temperature is a bit high or low, each batches of bread will taste different. Some may taste too salty, some may taste too sugary, some may taste burnt bread. So what you need all this? You need a controlled process. You have to make sure everything that's added to the raw material while making are of optimized quantity. Like if the bread baker wants to add 4 grams of sugar and 4 grams of salt to make a good bread, the machine that's adding all these ingredients should follow the exact process. So, and the baker wants the bread to make at 100 degrees or 70 or 80 degrees baking temperature. The oven should bake the bread into at the same temperature. What if it's deviate from what we asked to do? It will create a different end product, and the customer won't like it, or nothing will be sold. So everything that's happening in the manufacturing process needs to be very in a controlled manner. And the last one is the machine availability. So all the manufacturing factories have a lot of machines, and all the machines has to be operational. If one of the machine breaks down, for example, if the oven is breaks down, the whole lines will be stopped. So the output will be 0. So it will be a huge loss to the manufacturing company. And they won't have any output for the bread. So these are the main points for a manufacturing. I said here just to make the students know what goes on the manufacturing side, how critical each and every steps are in order to get a good product out of the factory. So far you have gone through what sand is and why sand is important, and the silicon, the main component of the sand, which is used to make transistors, and how the transistors are made. Yeah, so I forgot to add the quality checks. You need a quality check at the end to make sure the products going out are of good quality. So that's the end of my little talk. I want to end with a quote here to the kids here. Science of today is the technology of the tomorrow. It's by Edward Teller, who is considered as the father of the hydrogen bomb. And I want to thank all the audience and the organizers of the Curiosity 2018 Ireland. Thank you.
Now moving on to the next lecture, I will pass the mic to Advocate Jitin Ram. And he's going to talk to us about the daily, the use of science on a how we use science on a day-to-day basis. As we all know, without science, there is no existence of human beings today. We all came down here because of the use of science. We need science on a day-to-day basis for one thing or the other. So let's see exactly how we use science unknowingly or unknowingly. And for that, I request Jitin Ram to deliver the lecture. Thank you.
Yeah, there are a number of ways science affects our day-to-day life. The sun rises. When we wake up in the morning, the alarm rings. There is a science in it. When we walk, the gravity is there. There is a science in it. When you take bath, the pump, there is a science in it. Pumps the water. So there is a science in it. When you eat food, you heat your food in microwave oven. There is a science in it. So everywhere there is a science in it. When you go to school, you use your shoes. Why? To reduce the friction, not to fall down when it is wet. So there is a science involved in everywhere. Every walks of your life, science is there. When you go to school, teacher do a presentation using a projector. There is a science. The microphone I am using, there is a science. Everywhere there is a science involved in it. So when you go by a car, there is a science. There is a 2-stroke car. There is a 4-stroke car. Every walks of life, there is a science. Without science, there is no existence for us. That is the beauty of science. So always think logically and think in a science perspective. Okay, I would like to start the lecture with how days and nights are caused. How many of you know how days and nights are caused? Raise your hand. Many of you know how days and nights are caused. That's a good thing. How many of you know? Raise your hands. I'm going to ask you how days and nights are caused. So you can see the sun and the earth. So which rotates? You tell me which rotates. Sun rotates or the earth rotates? Yeah, the earth. There's a sun. You can see a sun there, and the earth rotates on its axis. Sun there's earth rotate on its axis. It will take 24 hours to do one rotation. For one rotation, it takes 24 hours to do one rotation. So one rotation when the earth is doing, one side of the earth will come. That is day, the other side is night. When night comes, the other side is day. It happens. If it is day here in Ireland, it is night in Australia. Right? If it is night in Australia, there is day in India. Or in Australia, see, Earth is divided into two. One is northern hemisphere and other is southern hemisphere. Which all countries come in northern hemisphere? You can tell me which all countries come in northern hemisphere? Yeah, go ahead.
Ireland.
Yeah.
Ireland.
Yeah. And you?
Russia.
Oh, good. Yeah, you? What's that?
Czech Republic.
Czech Republic. A rare country.
Spain.
Yeah. And which all countries come in southern hemisphere? You can tell me which all countries come in southern hemisphere. Koreans, go ahead. South Africa in southern hemisphere. Yeah. India in northern hemisphere. Please, India in northern hemisphere. Which all continents are there in the northern hemisphere? Tell me. Yeah, Europe is there in the northern hemisphere. So there is no talk about northern and southern hemisphere. How many of you know how seasons are caused? How many of you know how seasons are caused? How seasons, how summer season, how winter season, how spring season, how summer season, how winter season, how spring season, how autumn season. How many of you know? Yeah, you can tell me.
The Earth is tilted when when it spins on its ellipse. It will cause different seasons.
Yeah, that's good. That's good. You can say, see, the seasons are caused because of the tilting of the Earth. See, you can see that diagram. The diagram is so small. You imagine this is sun and the Earth rotates. The Earth has a tilt there. That tilt will cause the summer season and the winter season. Again, the same logic. When the tilt is there is summer in Ireland and there is winter in Australia. And where is winter in Australia, winter in New Zealand, there is summer in Ireland. This is the difference because of the tilt that is happening. Tilt in that elliptical orbit, it is happening. Okay, why seasons are caused? It is because of the tilt. How days and nights are caused? It is because of the rotation of the Earth. So two things we learned. So we are now going to sea breeze and land breeze. How many of you know about sea breeze and land breeze? How many of you know about sea breeze and land breeze? Because I am going to tell rainfall from sea breeze and land breeze. That's good. You told something. You can tell me. What is sea breeze and land breeze? Sea breeze and land breeze. Sea breeze and land breeze. Yeah, you can tell.
Is it meant to be like wind over the sea and wind over the land?
Oh, that's great. I'll tell you why this is happening. Okay. So, sea breeze and land breeze. Earth is here, the sun is up. So, because of the solar radiation of the sun and the emission from the down, the earth gets heated. When the earth gets heated, the air particles will go up. When the air particles will go up, there is a high pressure in the sea and a low pressure in the land. When the air particle will go up, there is a low pressure in the land. There is a high pressure in the sea. So, high pressure and low pressure. So, air flows from the high pressure area to the low pressure area. Then what is called, that is wind. So, it is coming from the sea. We call sea wind or sea breeze. So, I'll tell you again. There is a high pressure in the sea and the low pressure is created in the land. When the air particle heated up and the air particle will go up, there is a low pressure down. Then the wind flows from the high pressure to the low pressure. That is wind. It is coming from the sea. So we will call it as sea breeze. Then what is land breeze? Then what is land breeze? The opposite will happen. In night, what happens? The water cools rapidly. So the low pressure is there in the ocean. In morning, high pressure is there in the ocean. In night, low pressure is there in the ocean. Okay, in morning, high pressure is there in the ocean. In night, low pressure is there in the ocean. So, the wind flows from the land to the sea. That is called land breeze. I don't know whether somebody is from the coast of the beaches. I think your parents can also tell you. You may be from coastal areas. Anybody of you from coastal areas? Almost all the Keralites are from coastal areas. So, you can experience sea breeze. A kadalkat, sea breeze in the morning and land breeze at the night. Okay, that is the beauty of people who are staying in coastal places. So, sea breeze and land breeze. So, with same concept, I am going to explain rainfall. So, how many of you know how rainfall is caused? How many of you know how rainfall is caused? You know how rainfall is caused? Yeah, tell me.
Water vapor rises from the ocean into the clouds, and when the clouds get heavy, it pours down.
Explain well. See, this logic of sea breeze and land breeze can be applied to explain the monsoon of tropical areas. Same logic is there for the rainfall of monsoon in tropical areas. The logic of sea breeze and land breeze. So we are taking the same logic here for the rainfall also. Due to the heat of the solar radiation, the air packet gets heated, or if you take that in the ocean also, the water gets heated and the vapor will go up. The vapor will go up. What happens? The vapor will go up. The vapor will, because of the environment lapse rate, the vapor will, what happens to the vapor? The vapor will cool and vapor will form water droplets. And these water droplets will combine. These water droplets will combine to form clouds. And there is more water droplet, more clouds. Then after some time, it is very difficult for them to hold the clouds. Then it will come back as rainfall. So again, I am going to tell you, the air packet, the water will go up. what happens then? It cools, the water droplet will combine into clouds, and the clouds is unable to hold it, it falls as rainfall. That is one type of rainfall. Okay. So what all we had seen? What all we had seen? So what all we had seen? We had seen day and night. We had seen day and night is caused because of the rotation of the earth. And we had seen seasons, that is because of the tilt. And we had seen sea breeze and land breeze. Then we had seen rainfall. Okay, moving further. Yeah, can you tell me the difference between weather and climate? Can you tell me the difference between weather and climate? Raise your hands and tell the proper answer. Recently, there is a tweet to the Trump, American President Trump. Trump went wrong in saying that he does not know the difference between weather and climate. So Trump was wrong, and a schoolgirl from India tweeted to Trump saying that this is the difference. So you can make a difference by telling the difference. Tell the difference of weather and climate. A tweet to the American president. You can even imagine.
Climate is the weather in an area over a long period of time, whereas weather is for a week or the kind of thing.
Right. Yeah. Weather, what is weather? Weather we normally say about a day. Today's weather is mild or today's weather is cold. Climate is an average of 3 months. That is what climate means. So weather we normally talk about a day. Climate is an average of 3 months. So that is the difference between weather and climate. Fine. Can you tell me what are the ways of heat transfer? What are the ways of heat transfer? There are different modes of heat transfer. You can see on a regular basis there are different modes of heat transfer. What are the different modes of heat transfer? Tell the senior students. Yeah, conduction, convection and radiation. These are the different ways of heat transfer. Then I'll take on conduction. What is conduction? Conduction, yeah? You're telling all the answers. I'll ask somebody else. Yeah, what is conduction?
Oh, no, I thought you said convection.
Yeah, conduction.
No, I thought you said convection.
Oh, okay, conduction. Conduction, what is conduction? Huh? The movement of heat between solids of different temperature. When you know that, when you touch an iron rod, what happens? Suddenly, if your hand is cold also, your hand will become suddenly heat. That is a way of conducting things. When you start an engine also, there is a conduction happening there. So there is a conduction happening all around us. What is convection? Convection is the same heat transfer movement which is happening in fluids. Fluids, liquids as well as gases are called fluids. So convection is the same type of heat transfer which is happening in fluids. Fluids means liquid as well as gases is there. You know, the process of rainfall itself. See, in some areas, rainfall is called convectional rainfall. In equatorial regions is, if this is earth, the 0 degree, that is equator. There are a lot of oceans in equator. All Pacific Ocean, Atlantic Ocean, all other. Even Indian Ocean is there in the equator. Their convectional rainfall happens on a regular basis. So convection rainfall happens on a regular basis. There is the movement of water through this convection happening. So there is a convection rainfall happening in equatorial region, and there is a 4 o'clock rain almost on a regular basis in equatorial regions. Can you name some of the countries in equatorial regions? Can you name some of the countries in equatorial regions? Can you name some of the countries in equatorial regions? All South American countries, Brazil, Venezuela, coming back to Africa, Uganda, and all those countries in equatorial regions. So you can see a regular basis rainfall, 4 o'clock rain. That is known as 4 o'clock rain, and that rainfall is known as convectional rainfall because of this convection, that rainfall is happening. So that is convectional rainfall. Moving further, what is radiation? What is radiation? What is radiation? Yeah? What is radiation? Yeah. Yeah. You win, sir.
Is it heat vibrating?
No. What is radiation? Yeah. You hear? They're so smart, the kids.
Is it when heat radiates?
Yeah. That's fine. When It happens in the gases. When heat radiates, you can imagine sun. What is happening sun? That is radiation. So normally we call the heat from the sun as short wave radiation. And the sun's heat coming back to the earth, then the heat emitted, that is known as terrestrial radiation. So radiation can happen at many places. So the sun's heat in radiation, how many of you know how atmosphere is heated? How many of you know how atmosphere is heated? Yeah, how many of you know how atmosphere is heated? Yeah. How atmosphere is heated?
Well, the clouds trap the heat.
How atmosphere is heated? Simple question. How atmosphere is heated? Yeah.
Is it pollution?
No. How atmosphere is heated? How atmosphere is heated? See, atmosphere is not directly heated from the solar radiation as we all imagine. So we all imagine like atmosphere is heated by the Earth's solar radiation. A part of atmosphere is heated by the Earth's solar radiation. The radiation coming from the sun is reflected back through clouds, through dust particles. It won't reach Earth. Only 34% of the Earth radiation which is coming from there is coming to the Earth. Then what happens? Our surface of the Earth reflects back. So our surface of the Earth reflects back. So our atmosphere is heated by the reflection back of the, that is known as terrestrial radiation. Atmosphere is heated by terrestrial radiation. So you can actually logically think this. When you go higher up in the altitude, the temperature decreases. Why? If atmosphere is heated by solar radiation directly, the heat would have been more in higher altitude. But atmosphere is not directly heated by solar radiation. So it is heated by terrestrial radiation, which is the radiation happening from the Earth's surface. So when you go higher up in the hills or mountains, you can feel the temperature is decreasing there. So that is what happening in the radiation. So from this, I'm going to end my lecture. I'm not going to bore you by taking the class further. Thank you.
Thank you so much. Now moving on to the next program, can I request Dr. Suresh Pillai, who is going to talk about the importance of project-based learning. And as you all know, the US and the UK and most parts of Europe are giving a lot of importance to project-based learning. And he's going to give us a lot of insight on why that is so important. As you all know, Dr. Suresh Pillai needs no introduction, as I said earlier on. He is the senior lecturer at Sligo Institute of Technology, Department of Nanotechnology. He's won a lot of awards nationally and internationally. Can I now request Dr. Suresh Pillai onto the stage? Thank you.
What a wonderful presentations this afternoon. You all guys did a wonderful job. I learned a lot. What I'm going to talk is what you have been doing in the past couple of hours, which is the project-based learning. When I was in primary school, in a village in Kottayam district, I was in the 4th class, which is around 9. My age was around 9. And my teacher was Elizabeth. And she started to teach the solar system, as you guys have been doing here. And nobody could really get that. What is solar system, how it works, how the sun is centered, and how the other planets are revolving around sun island. She taught, and then she said that, let's do this. How about she selected 10 students, and that time, if you remember, there were 9 planets. Pluto was also included that. in the solar system that time. And she asked all of us to bring banner. And my banner was, I remember, Mars. And we all went out. So it was a big job, so everybody was excited. All were engaged and prepared their own banner. And we went out. And the sun was there, and she asked all the planets to revolve around the sun. And that was the first PBL I was involved. And that's the only thing I remember from my primary school. Or that is one of the few things I remember from my primary school. So this is the best way to teach your children. PBL is very, very important. So which is as simple as the type of learning and what people do in the everyday world outside the classroom. PBL is very effective. So in a traditional or a conventional way of teaching, it's more teacher-centered. Or what I would say is a kind of problem-solving way of learning. And which is arriving decisions based on prior knowledge and reasoning. But in the modern way of teaching, it's the problem-based learning, which is the process of acquiring new knowledge based on the recognition of a need of a team. It's a teamwork. That's exactly what you have been doing. And you are not going to forget whatever you are talking this morning. And you will carry that throughout your life. And whatever you do based on this type of activities, you are not going to forget it. So the process of PBL or problem-based learning is, first is identify a project. Then you have to form a group, 2 or 3 or 5 people. The next thing is research or get prior knowledge. What is already done there? You have to understand what is already there. So you need a lot of research from the website. You can talk to people who knows about it. And then you form, then within your group, you have to start discussing what you understand. Then you can see, once you know what is already there, then you can identify the gaps, what is not there. That's how the knowledge develops. Then you can set strategies, start gathering additional information, develop it, assess it, and make a report. That is how the process of PBL works. And it is student-centered. You decide it. It's not based on the teacher. Teacher can be a part of it. Why PBL is important? It is because it is a long-term retention of knowledge. The same example I said in the beginning of the talk, the solar system, Elizabeth teacher taught us. Okay. So that's a very famous Chinese proverb. Tell me, and I will forget. Show me, and I may remember. Involve me, and I will understand. Okay. Tell me something, I'm going to forget it in future. I may not remember that. If you show something, if you demonstrate something, and you may remember it. But if you are a part of it, if you involve it in it, and you are going to understand it. So as I said earlier, students are the center of a PBL system. So in a PBL setting, students are using the technology for the outside world. The connection to the real world is what makes it different. So you are making connection to the outside world. You are acting as the teacher. You are acting as your own teacher, or your group as a whole works as a teacher. And teachers can be coaches. So in the PBL setting, teachers are not really teachers. Teachers can be advisors or coaches. And you direct it. And you involve it. You develop it. That's how you learn it. And you are never going to forget it. So what we are actually going from is a teacher-centered process or teacher-centered process to a student-centered learning process in which the student leads the process. You are leading it. You are getting knowledge from the teacher. So the full control is with you. In the PBL setting, parents and community can also contribute a lot to students. Whenever you get free time, take your children outside and you can start small projects. Start talking to them. And that's how they learn it. You are involving them in the studies or in the research. So this is how it's learning to learn. It's from the peers and also it's cooperative learning. And this is a part of the lifelong learning. And learn best by doing it. Think about how you learn cycling. After a lot of failures, you started to learn how to cycle. Same as swimming. It takes time. So, PBL is the same. It's a kind of lifelong learning system. And PBL or project-based learning connect students with the real world. Technology can be a part of it. And technology is not the only part of it. Teachers can be a part of it. But the students or the learner is the center part of it. How we can do PBL? If you have difficulty in mathematics, for example, trigonometry, this is just a small example how PBL can be demonstrated. You learn the equations for sine theta, cos theta, tan theta, and all. That's the conventional way, that's the way I used to learn. Just to remind the equations. Sine theta is equal to opposite side by hypotenuse, and cos theta is equal to adjacent side by hypotenuse, and tan theta is equal to opposite side by adjacent side, or sine theta by cos theta. This is the way we learn it. And this is the way most of the students learn it at school. You can make it as a project. You are definitely going to forget it if you learn by just remembering the equations. So if you can take your child to outside, make it as a project. For example, if you want to measure the length of a tree, take it as a project. Very simple things you need. A protractor or a clinometer. You can make it using a straw and something heavy. a rope and something heavy can be attached to it. Mathematics, biology, history, you name it. Any subject can be learned by using PBL. Very effective. So how PBL help your studies? It can be a tool for studying difficult and boring subjects. If history is boring for you, make it as a project. If a part of history is boring for you, make it as a project, like the example we discussed earlier in the Second World War. Or if trigonometry is difficult or boring for you, make it as a project. Measure the height of a flat. Or make a project for measuring the height of a tree. Make simple projects or small projects and learn from that. And that will also improve your communication skills. You are going to talk to people. You are actually living in the real world. And that will develop critical thinking and problem solving skills. And you direct it. As students, you are the center of your project. And teacher is only a part of it. So I'm going to conclude it, and the take-home message is, tell me, and this is mainly for parents, tell me I will forget, show me I may remember, involve me, and I will understand. So, take your children to outside world, make small projects, and if they have difficulty in some of these subjects, or any subject they feel it is a boring subject, make it as a project. That's how they can make your studies interesting. And with that note, I would like to conclude, and I would like to thank the organizers for organizing such a nice event. And I'm sure that next year, the audience will be 3 or 4 times than this one. Well done again, guys. Thank you.